Hello students and welcome to another lecture on logic design. In this video we will continue to learn about complement arithmetic in the octal number system. As you know, the octal number system has a base of 8. So it will have the diminished radix complement as the 7's complement and a radix complement as 8's complement. The diminished radix complement for the octal number system is the 7's complement. Recollect from a previous video that to find the 7's complement of a decimal number, you need to subtract each decimal digit from 8. Also, if you want to find the 8's complement of a octal number, then you need to add +1 to the LSD of the 7's complement in order to get the 8's complement. There is a method to do 7's complement arithmetic and it looks like this. You will understand each of these steps with the working of an example. I want you to make note that this method is very much similar to the 9's complement arithmetic. Let's take an example. 462 minus 175. Note that both these numbers are in octal. In subtraction, the first number is called as the minuend and the second number is the subtrahend. Let us also bring up the algorithm we saw in the previous slide. The first step tells us to add the 7's complement of the subtrahend to the minuend. The subtrahend in this case is 175. Find its 7's complement by subtracting each digit from 7. We get the answer as 602. The step also tells us to add this to the minuend, which is 462. So adding this up, we will get some answer. Now remember that this addition is an octal. So 2 plus 2 is equal to 4 in decimal, which is valid in octal as well. Next, we have 0 plus 6, which is equal to 6 in decimal, which is valid in octal as well. So we get the answer as 6. Now we have 6 plus 4, which is equal to 10 in decimal, but this converts to 12 in octal. So we get 2 with a carry of 1. Now we get the sum as 1264, where the MST 1 is the carry out from addition. I have highlighted this in grey. Now this carry is a special carry which is called as the end around carry. The algorithm tells us that if there is a carry, then the answer is positive, which is pretty obvious since the first number is bigger than the second number. It also tells us to bring that carry around and add it to the LSD. So let's do that. Bringing the carry around and adding it to the LSD, we get 265, which is the answer that we are looking for. There is another step to do, but we will tackle that in another example. Let's rearrange the numbers as 175 minus 462. Both these numbers are in octal. Let us bring up the algorithm that we saw in the previous slide. The first step tells us to add the 7's complement of the subtrahend to the minuend. The subtrahend in this case is 462. Find its 7's complement by subtracting each digit from 7. We get the answer as 315. The algorithm also tells us to add this to the minuend, which is 175. So adding this up, we will get an answer. Now remember that this addition is an octal. So 5 plus 5 is equal to 10 in decimal, which converts to 12 in octal. So 2 and there will be a carry of 1. In the next column you have 1 plus 1 plus 7 is equal to 9 in decimal, which is 11 in octal. So 1 with a carry of 1. Now in the last column we have 1 plus 3 plus 1, which is equal to 5 in decimal, which remains 5 in octal. So we get the sum as 512. Notice here that there is no carry. The algorithm tells us that if there is no carry, then the answer is negative, which is pretty obvious since the first number is smaller than the second number. It also tells us that the answer is in 7's complement form. So we need to find the 7's complement of the result to get the final answer. So let's do that. Finding the 7's complement of 512, we get the answer as 265, which is the answer that we are looking for. Don't forget to put the minus sign since the answer is negative. That's all for now. There will be new videos on 8th complement arithmetic coming soon. Connect to the classroom for more videos and learning material.